Hello, guy. Today, I choose a topic: align access sorting for multi-core SIMD processor. We have several topics. I choose one of them. I want to present today for you guys. I hope this presentation will be helpful to you guys. Yeah. The topic I choose that access sorting for multi-core SIMD processors by 3 PhD, and the name of team. Yeah, different modern high-performance processors provide various hardware traits within one single physical processor with different cores and simultaneous multi-threading. SIMD, what does it mean? First of all, I want to say, what does it SIMD, SIMD? Single instruction multiplied data. It's a type of parallel processing in the planes taxonomy. SIMD can be internal, part of hardware design, and it can be directly accessible through a instruction set architecture, ISA. SIMD describe computer with multiprocessing elements that perform the same operation on multiple data points. Also, many processors are now providing a set of single instruction multiple pipeline, that's SIMP instructions, such as the VMX instruction set. They have the ability to operate on multiple data values in parallel, so that they can easily lead to acceleration of computationally intensive program for various applications. The significant feature note with the SIM instruction is they lead to parallelism of instruction and ensure that the program reduce the conditional branch that they have in their program. In some cases, it is notable that branches are likely to include pipeline installs and hence reduce the performance of the superscalar processor through the use of the line pipeline stage. Sorting. Sorting is regarded as one of the essential operations for commercial application, especially database management system is in any given organization. Hence, the different parallel and sequential algorithms have been studied in the past. We already studied about that in the past, but the common algorithms cannot exploit the SIM instruction, single instruction, multiple pipeline instruction, such as the quick sort. Different sorting algorithms are featured to demand element-wise or unaligned memory access, which lead to additional attenuation and overhead of the benefit of the SIMP instruction. Align access sort, AS sort. Align access sort is featured as a sorting algorithm that can exploit both the SIMP instruction and the thread level parallelism note in the different multi-core processors used with today. We have type of align access sort. We have two models. One of this the in-core sorting algorithm, other is out-of-core algorithm. Both algorithms are significant and work take advantage of the same instruction. Also, they can run in parallel with the use of multiple thread. The algorithm is featured extending the consort and making it easy to eliminate all of memory access that they are not aligned and fully exploit the SIMD processor. The key idea that is the use of to improve the consort is the focus of the first sorting the input data into the transpose the order and then records it into the desired order. The computational time for algorithm, this algorithm is on average is featured to be n log n in the worst case. It has the disadvantages such as having a poor memory access locality. Out of core sorting algorithm. This is featured as sorting algorithm that helps reduce the disadvantage node within the in-core sorting algorithm of the align access sort. There's AA sort. It is an algorithm that is featured to make the inter-align access sort algorithm to use the cache memory efficiently. It is featured to work based on the merge source and use the new vectorized merge algorithm. The locality of memory access is better than on note in the in-core sorting algorithm. The computational complexity of this algorithm is featured to be O n log n in any given worst case of the algorithm. And now I give you, once again, now I give you guys a sample for application. I give you two different models. One of them is use the PowerPC 970 MP processor, and another one is cell broadband engine SIMD processor. A typical example is not with the ASO accuracy featured and evaluate on 4 core of the PowerPC 970 PM processor and a system with 16 core of the cell broadband engine cell BE processor. It can be noted that the sequential sorting of the AS sort algorithm through the use of the SIMD instruction outperform that of the optimized sequential sorting library of IBM 1.8 times, and GPU trustsort with the feature to be an exciting state of the art sorting algorithm for SIMD processor by 3.3 times on the PowerPC 970 MP when it is applied to sort 32 of the random 32-bit of integer. And another significant example is the AA sort has better scalability with an increase in the number of core compared to parallel version of the GPU. The trust sort, it can achieve a speed of to 12.2 by 16 core on the cell B is GPU trust sort can only accomplish 7.1x. Therefore, the algorithm is featured to be 4.9 times faster on 16 core of the cell B processor and the 4.2 times faster than 4 core of PowerPC 970 PM compared to GPU trustor. This is an example of two different models. I compare them to each other. Our execution of AS sort. AS sort consists of two major algorithms that work to ensure that the sorting process is accomplished accordingly. This algorithm includes the in-core sorting algorithm and the out-of-core sort algorithms. The overall execution of the AS sort takes the following phase. I want to talk about them. Can use two algorithms. Use of the two algorithms there. One is the first of all is dividing all the data into blocks that can fit into processor cache, then sorting every block with the in-core sorting algorithm, and final merging the sort block using the out-of-core algorithm. Now, I want to more discuss about two different models. The main aim of using the in-core algorithm of AS sort is to help the improving of the comp sort. Comp sort, what is comp sort is featured to be an extension of the bubble sort. Bubble sort is a sorting approach that is featured to compare each element to the next element and swapping them if they are featured to be out of the sort order. On the other hand, comp sorting is featured to work through comparing and swapping two non-adjacent elements. The primary operation of different sorting algorithms included comp sort, GPU tetra sort, and biotonic merger focus on the comparing two values and swapping them in case they are out of order. This makes the branch prediction hardware not to be able prediction the branches. However, it is essential to note that comp sort is featured to have two significant challenges that affect the effectiveness of the SIMD instruction. The challenge included different dependencies that are loop carried and accessing the unaligned memory. A loop carry dependency is featured to prevent the exploitation of the data parallelities of the SIMD processor when the value of the gap is featured to be smaller. I continued the discussion working on the in-core sorting. The significant step that the algorithm executed included sorting value within the cache vector in the n ascending order, then executing the comp sort to sorting of the value into transpose order, and then a record of the value from transpose in the original order. Other memory access, also the approaches are significant and can easily be implemented in data-dependent conditional branch. However, it is essential to note that the in-core sorting algorithm is featured with a challenge of poor memory access locality. Its performance can quickly reduce if the data doesn't fit into processor cache. We continue discussion about the out-of-core algorithms, also robust algorithm used for AS sort in the SIMD processor. The algorithm is featured to use the merge operation to contact the process of sorting. The algorithm is featured to use merge. It ensures that the merge operation takes advantage of the SIMD processor as it maintains the computational complexity of ON. This complexity is smaller than that of ON log N used for the odd even merge or even for biotonic merge. However, out-of-core algorithms feature to have lower performance than in-core algorithm when given a small amount of data that can fit within the processor cache. It is featured to achieve high performance when data doesn't fit the processor cache. This is due to having a much better memory access locality than the in-core sorting that is featured to suffer from the challenge. Conclusion, the Alan access sort is discrete and already it exploits both the thread level parallelism and SIMD processor, does not need access to unaligned memory that lead to attenuation in the SIMD processor. This is my work site, the Apple Harvest, Hawley, and Gordon Rosen, one of the research, and the other one, 2, 3. This one is for multi-core processor. About that was Hiroshi and parallel multi-core, and another research is the Watkin number 4, 5, and I use some books and some other research. Thank you so much, guys. End of this presentation. If my accent or my pronunciation was not so clear, I want to say it. Anyway, I'm so sorry for that. I hope this will be helpful and you like this presentation. Have a great study in your life. Thank you so much.